Welcome to Embedded. I am Elecia White alongside Christopher White. Let's talk about PCB boards making themselves move and then soldering themselves and origami. It's going to be a good week. Our guest this week is Carl Bugeja.
Hi, Carl. How are you doing?
Hi, thanks for having me.
Could you tell us about yourself as if we met, well, I want to say at an origami convention, but yeah, at an origami convention, sure.
Sure. So I'm an engineer that lives on a tiny island called Malta, in the middle of Europe. So my job is to design weird and novel electronic projects and document all of them on YouTube.
And we will be talking about many weird projects. But first, lightning round, where we ask you short questions and we want short answers.
Okay.
Are you ready?
Yes.
What's your favorite fictional robot?
Okay. I guess it has to be Wally.
What is your favorite origami pattern?
It's got to be the crane or the swan, I guess.
Flexible or rigid PCBs?
Flexible.
Can flex circuits be made into origami?
I think so, yes.
Do you work on one project at a time, or do you have several in the queue?
Unfortunately, several.
How far can your fold-up rover go in one charge?
I think it can last around 15 minutes, but it heavily depends on how smooth the terrain is. So on rough terrains, it needs to have the battery fully charged to keep going.
Is that 15 or 50, like almost an hour?
15 minutes.
Okay.
If someone were to visit Malta, what restaurant should they go to?
It's hard to tell because there are so many restaurants here open in the last 5 years. It's a little bit crowded, to be honest. But there's a lot of Italian cuisine and stuff like that. So I think you have several options to choose from.
Do you have a tip everyone should know?
I guess to never give up on anything that you're working on, I guess, because somehow eventually you can get it to work.
That is a great tip. So I do want to talk about your origami actuators. DJ, a listener, sent in that video. But while we were talking about scheduling this, we then got another video about a fold-up rover and then another one about a self-soldering circuit. So where should we start?
Let's start with the actuator stuff, I guess, because that inspired a lot of the foldable rover as well.
So you folded a bird and a dog and a couple other things, and you had them flap using a magnet and just a flex circuit. There was no traditional motor solenoid thing. How does that work?
So the idea actually came about when I was so I had already developed the flexible actuator and the PCB actuators, and then I had one project where I tried to turn a heater into a sticker and see how and what applications it could be useful in. And when I was sort of testing it, I realized that putting an actuator on a sticker sort of doesn't exist and would be like very useful in some cases, especially in origami, because flexible PCBs are like paper thin. So the idea was to develop a sticker actuator that actually connects to paper, and sort of you could bring life into origami.
Going back to the heater, I actually worked on something similar. It's interesting because we were making a thermometer that was non-invasive, and so you stuck the heater onto somebody's forehead, and it had some insulation, and then you heated it such that there was no temperature gradient between the heater and the human skin, and that was a deep temperature measuring. I don't remember the acronym for it, but it was kind of cool. Have you done stuff like that?
So what I have done is try to apply sort of one time I had received an email from a scientist in Argentina, and he actually told me that he's using my actuators as heaters. So basically what he required is like a heater that is paper thin. So my flexible actuators were just 0.1 millimeter thick. And sort of I had this sort of, let me try and actually put a heater on flexible PCBs instead of using my actuators as heater. And there were quite a few interesting results in that experiment, I think.
Did you melt any flex circuits?
Yeah, I sort of tried to heat them at their to their limit. So basically, flexible PCBs are rated to 100 degrees Celsius, and what I try to do is to run a long duration test for around I guess it was 2 weeks or 1 month, something like that, because this was more than a year ago. And it actually, the PCB that I was testing eventually turned into this brownish color. It was still functional, and it was like non-reusable, but I mean, it was still cool to see that the limitations of these circuits. But then eventually I also learned that so flexible PCBs, there are different colors, and for some reason they are rated at different temperatures. So the black overlay should sustain higher temperatures than the brownish one. And that was the conclusion for that project, sort of.
You did something sort of similar with self-soldering PCBs.
Yes.
Could you describe it?
Yeah, that project was actually stuck in my head for around 5 years, and after thinking about it a lot, I eventually decided to give it a try. Viewers from my channel probably know that I first tried to create a PCB hot plate. Sort of my plan was to first create a hot plate, then try to tackle self-soldering circuits. I eventually found out that there's a lot there's a lot of things to learn from my side about PCB heaters, so it wasn't that easy as I thought it was. But eventually, I from all the testing that I have done, I have found that PCB hot plates are actually a very bad idea, because PCBs are not rated to go to high temperatures for long duration of times. So basically, the conclusion was that a PCB hot plate would be only used for 3 times or 4 times maximum until it start getting damaged. But this still still made the self-soldering circuit feasible, because you only have to solder the circuit one time for the self-soldering concept. And once I eventually reached that point, I tried to make the video as geeky as possible, I guess.
You said not long duration and one time, and that makes sense because, I mean, the boards have to get hot enough to be soldered normally.
Exactly.
And on the inside, if I remember correctly, you took a plane that might normally be a ground plane.
Exactly.
Instead of having it, all copper, you made little squiggles all around except for where there were vias.
Exactly.
How did that lead to heating? Did you have like a ground? Do you have a short to ground? How does that work?
So imagine like a resistor. When you pass current through it, it heats up. The same goes for a copper track. If the resistance is small enough, it will heat up. And my idea was to use low temperature solder paste to heat it up so that it could follow the soldering reflowing profile.
Are the squiggles to increase the resistance so that it heats up?
The squiggles are just to make the track longer, because you have to achieve the resistance have to be high enough so that the current won't be too high, and I would be able to just power it with like 9 volts or something like that, or 12 volts. That is why I try to increase the resistance as much as possible.
It was an interesting video that you could make one of these from another one of these, the whole mother baking the daughter thing. But would you do this in real life? Are there production uses for this?
I mean, for hobby projects, I think it's perfect. But for someone who doesn't own a reflow, perhaps, a hot plate. But for production, I'm not totally sure, because one of the biggest criticism that the project received was that sort of in engineering school they teach you that ground should have the shortest path as possible for high-speed circuitry. So most probably this circuit would either does not pass something like an EMC test or something like that, because it actually has a very bad ground plane, even though I had a separate ground layer underneath it.
But you could rectify that by, right now you connect your squiggly layer to the ground layer to have 2 ground layers.
Exactly.
But if you just, instead of connecting it, left it floating, then that wouldn't matter, would it?
I don't think that would matter, but I am planning to do some more testing on this so that I can perhaps create even a better version with less squiggly lines and a shorter path to ground. I'm still sort of brainstorming at the moment on how I can create a better version. But I mean, it's for me, it was just a cool concept that I had to try out.
I think it's one of those concepts that is so novel to me anyway, that I can't readily see the application, but I know there must be some really cool application for it that I'm missing. And this is not a criticism. This is so outside what I would expect somebody to do that I have to process it for a while. But I mean, it's kind of along the lines of, all of the self-assembling or self-repairing kinds of things like von Neumann machines and all that, that I feel like, okay, maybe something that needs to repair itself could have a whole array of these layers and okay, well, this isn't working. We'll try to reflow this one part of the circuit or something like that. But It just seems like there should be really, really important applications of this.
Yeah, I mean, for repair, it would definitely. There were a lot of comments suggesting it to be used in repairs, or even for something that has like a critical data, where if, for example, if stolen, the PCB has to self-destruct, or someone even suggested using the heater to keep satellites warm from the cool environment of space. So there's a lot of areas where this could actually be useful.
I was starting to think of things like places where you don't necessarily have all the tools you want, but it's difficult because you also do have to solder paste it and put all the components on. So it's not like you can do it in a field test unless you have a very quiet place to be. But I started, could you do it in space? Why would it be better to do this in space than to have it heater? Or could you do it in Antarctica where you don't necessarily have everything and you want to be able to configure circuits on the fly?
Yeah, it can be portable, I guess, by just connecting a battery. But the space idea was just related to keeping the actual circuit warm, not soldering it, I guess. But I guess it can also be soldered in space, but it would be messy, I guess.
Well, it's more, if you went to Mars, what would you need to take with you? At some level, you don't know what you need to take with you, so you need to take flexible things. So it was same perspective as Antarctica for me.
You could also selectively blow parts of, like if you had like a whole array of these, you could address parts of the circuit with a heater. You could like blow fuses that way, I guess. Or
well, he did say
blow up an EEPROM. Just one though, not the whole thing. I'm gonna selectively modify the circuit.
But you also, in an effort to scientifically determine the maximal limit, you also set one of these on fire, which I found highly amusing. How far did it go? What was the power where it just said, no, I'm not ever going to work again?
So PCBs are rated, their material are rated on a parameter called TG rating. So usually the highest rating, for example, for the PCB that I used was 170 degrees Celsius. I'm not familiar with Fahrenheit, I'm sorry. You can translate it if you'd like.
Hot, very hot.
Above 300, way above boiling.
So trying to heat up the thermal track higher than that value will damage the PCB, especially for long durations. And in that test, I think I powered the track with around 30 volts, if I'm not mistaken. So that brought up the temperature way high. And the interesting thing is that since that squiggly track, once the PCB starts sort of getting damaged and sort of like getting melted, the tracks themselves start to get shorted. So by that process, they're essentially lowering the resistance even more, so sort of like creating a bigger damage.
A cascade effect, yeah.
Exactly.
We just need more current after that.
Exactly.
Okay, so how do heaters relate to flap actuators?
They actually relate a bit, because one of the limitations of PCB actuators are the thermal limits of the PCB. So like I said, for flexible PCBs, for example, the maximum temperature it can withstand for it to be okay is 100 degrees Celsius. So when passing current through the copper tracks, it will obviously heat up, even though it's a coil, not a PCB heater. So that is actually the limitations of the coils themselves, is that they have to operate within the maximum temperature ratings of the PCB.
Oh, okay. So it's basically if you take a flap actuator and use it too much or power it too much, it will burn itself out.
Not at a much higher voltage, it will, but even at, say, I usually try to keep their voltage ratings below 5 volts. But even say if you say power it at 8 volts for like 1 month, it will eventually damage itself.
And we haven't really described what the flap actuator
that's hard to say.
Looks like. And I think the way, and since we're, podcasting, that's always a challenge. But I think the way to start is with the circuit pen that you used to make one of these on paper. Can you describe that?
Yes. So that idea came about when I tried. I just bought some conductive ink, and I was playing around to it, trying to make a coil that was similar to my PCB actuators. The downside of that project was that conductive ink has a low conductivity when compared to copper. So the effects are not as the coil's magnetic field is not as efficient as the PCB one, but I mean it worked, and I did manage to attract paper with magnet. So
these are basically deconstructed solenoids in a sense, right? You've got a coil, and then it's acting on a permanent magnet.
And the coil just looks like a spiral.
Yeah. So you apply.
It's like a very, very inefficient electromagnet. That's how I like to describe it.
Yeah.
It's an electromagnet without a core.
And so the flap actuator goes between two magnets if you want it to go all the way back and forth. Is that right? Or does it only need one?
The current flap actuator that I have only has one, because I had a whole project trying to. Because at one point I first were making these actuators for fun. Then at one point I tried to create. I was getting into like the robustness of these flexible PCB actuators. So the reason for this was that I started observing some failures when I was sort of like powering these coils for like 1 week or 2 weeks. So the goal was to create a flap that could sustain, sort of could be powered for like a year or two. And the advantage, the good thing about this is that now I sort of have like a template for a flap actuator that can actually be robust and be used in projects like mechanical displays, and where I'm now confident that it wouldn't fail for a long duration.
Mechanical displays. Say more about that.
Yeah, so one of my future projects will be a display made out of these flaps. It will be sort of like a mix between a flip dot display and kinetic sculpture. And like I was saying, if I haven't just focused on the durability of these flaps, going for this new project would be very bad, I guess, because it wouldn't last. It wouldn't have last very long.
I guess knowing that they can go for millions of cycles really helps the idea that this will last.
Yeah, exactly.
Pop-up books, electronic pop-up books where the people can move and stuff. I'm sorry, just thinking of other things you could do with this.
But I can't just drive this flex circuit from my normal processor. I can't just hook it up to an Arduino and hope that I don't source enough current to blow up my chip.
Yeah, Arduino won't supply enough current. What you need to drive it is either a MOSFET, a single MOSFET transistor, but that would actually control the current in one polarity. You can also use an age bridge where you could reverse the current and actually flip its polarity.
And that's how you get it to go back and forth.
Exactly.
When you want it to be close to the magnet, you have it go one way. If you want it to be far, you have it flip its polarity. And then you have a kit with those. They're the Flexar drivers. Those are the H bridges.
Yes. So I have a website called flexar.io, and there I sort of sell a kit where people can experiment with this directly. The driver, what it does is basically has 5 functions, and you can basically switch between each function to see, because the actuator, for example, can also be used for buzzing, making a sound. It can either be used in a square wave mode or in a PWM mode, where it sort of is driven with like a triangular waveform and stuff like that.
Have you looked at reversing it to make sensors? Like you could make a little paper keyboard or something?
Yeah, I'm not sure if it can actually be used as a pressure sensor, but it can be used as an inductive sensor. There are many applications and also development kits that are using PCB coils for inductive sensing.
Okay.
Where it can either perhaps detect a magnet or detect a metallic object. They have also showed it in some of my videos as well.
Make a paper microphone.
Yeah, we actually saw that.
Oh, did we?
I mean, I don't know that I saw it from Carl, but I saw something about it. Have you done a paper microphone?
I haven't done it yet. I mean, with these PCB actuators, because I guess it cannot generate.
Yeah,
its magnetic field. It would be too weak, I guess.
Have a big low noise amplifier.
Yeah, you would need a really large gain, I guess. It would be a fun project, though, trying to do that.
So you show these on YouTube, and you sell these little kits, but they're all open source. So if I wasn't lazy, I could make my own. Do you make most of your money from YouTube?
Yeah. I make my income from 2 ways: from these projects and from the kits I sell on my website. Even though all my projects are open source, the good thing about YouTube is that first you're documenting everything in your videos, which would be very helpful to a lot of people. while doing this, you will be also building a community, which obviously by watching your videos will help you make more videos. Then I also have a Patreon membership, where I have a lot of members that are supporting directly my project. And I also have a couple of sponsors that fund the PCBs and actually the projects themselves.
How did you get started? What came first, the kits or the videos?
The videos came first. So my first video on YouTube was about the PCB motor, and then I spiraled my way down to PCB actuators, flexible actuators, and stuff like that.
How does a PCB motor work?
So a PCB motor works like every other three-phase brushless motor, but instead of having wired windings, the coils are printed onto the circuit themselves, and then you have a rotor on top with a couple of magnetic poles, and by providing commutation signal, the rotor rotates.
So you're doing the whole three-phase commutation. Where you are right now, it depends on what signal you get, because you're trying to throw the motor around based on changing electrical signals.
Yes, it usually in a closed loop orientation. It's based on the position of the rotor.
That's hard. I did that once, and I managed to get some beautiful oscilloscope traces, and yet
the motor just kind of flailed around.
No, the motor would go around. I just burnt out FETs like crazy.
Oh. Yeah, it's pretty. When I was a student, I was sort of creating like a brushless motor ESC, and it was pretty hard and challenging to do it, because you have to have very, very efficient code to get the motor rotating at very high speeds. Because if you have just a little delay, it will lose commutation. And
this is one of those cases where you actually truly need real-time response. You can't have any latency. You can't do this in Linux.
Exactly. I don't think so, no.
Depends on your Linux. I'm sure if you applied enough CPU power to it.
I don't know.
I don't know either. I don't know what I'm talking about.
I mean, for low speeds, I'm pretty sure you can do it, but for very low speeds motors, I'm not sure.
It becomes untenable pretty quickly. I used a TI Piccolo because those seem to be very designed for this problem. But I think in your video, you're using a PIC something?
Yes. So my ESC was sort of went through phases, because at first I started with a PIC 16F, then I switched to a DSPIC microcontroller. Then for the rover, I switched again to the PIC 16F because the DSPIC was out of stock everywhere. So it's at the moment it's pretty all over the place, but I'm planning to make a whole video just about speed controllers and how it can actually I will go in more detail about PCB motors and why how you can select the most efficient ESC for your PCB motor application.
Cool. I look forward to that one. And please add some oscilloscope traces because they're so pretty.
So make sure I understand. So the PICs are being used solely as speed controllers. So if you wanted to drive several motors, you're going to have a higher level microcontroller that's talking to all the PICs and telling them how to adjust their speed.
Yes.
Okay.
That's how my rover was working.
Oh, okay.
So it had four PIC16F microcontrollers, and the ESP32 was talking to them, basically just sending the speed.
And the ESP32 is also talking to your Xbox controller?
Yeah, I was using a PlayStation controller.
Over Bluetooth?
Yes.
Oh, neat. Okay. I think I missed that from the videos, how that was connected. So that's cool.
So this rover that we're talking about, like everybody's thinking like a mouse droid from Star Wars, something, at least calf high. But this is tiny.
Yeah.
How big is your rover?
I don't think I ever measured it, but it's quite small. It's around, I think, the battery was, I believe, 4.9 centimeters in length.
And the battery is pretty much the length.
Yeah, exactly.
I think the wheels go a little beyond, depending on which you have printed up.
Exactly. It's around 5 centimeters in length, something like that.
Yeah, it was tiny. And that, of course, causes its own problems because it's not heavy, which makes it easier to go, but harder to get traction.
Okay, so the rover, the hook of the rover is that it uses these PCB motors, but actually the structure is also PCBs. So it's like
it folds into itself.
Folds into itself, right?
It folds into a cuboid.
Did you ever try tracks instead of wheels?
I haven't, but it's one of like the main points that is highlighted for the next version. So I but before thinking about that, I'm just focusing on the motor and trying to squeeze a little more torque out of it. So my first step for this next rover is just going to be just focus on the motors and try to get more torque out of them.
How are you trying to do that? Like I can see that the PCB presents some limitations about how physically things can be structured. So what things can you adjust to get more torque?
Yeah, there's actually quite a long list. First of all, the most obvious thing that can be done is adding more poles. So currently my motor has 6 poles. Going for like a 9-pole motor would like increase the torque. The only problem with that is the area. So I'm still not sure if like if 9 poles can actually fit in that area, and if not, how much bigger does the motor needs to get. But then there's a lot of other stuff that can also be tested. Something like, for example, a lot of people suggest Hallback arrays, for example. My rotors are quite small, so I'm still not 100% sure that the magnets would fit inside that and have that orientation. But I mean, I'm still experimenting with a lot of stuff currently.
You put this experimentation style of development on your YouTube channel. You also put your mistakes on. How do you decide what you're going to put up? How do you decide what mistakes are too embarrassing to show on video?
I actually try to put everything in the videos, as long as it obviously follows the same arc of the video. But there are some things that obviously would be sort of would make the video like last forever. So for example, for the rover, I was having a problem with the the PlayStation joystick communication, because I had another joystick that was like a mock-up and it wasn't working with it. So I spent like weeks trying to solve that problem, and I eventually didn't solve it. But then it comes to how long will the video is going to last, and is it like important for the build. So there you sort of have to make some decisions, what to leave out and what makes like the video interesting.
It must be difficult to have the balance of making the video interesting and fun and entertaining, but also showing the engineering in a way that is understandable to the people who are interested in that sort of thing.
Yeah, it's very difficult. I think it's I'm always sort of not 100% sure how video is going to go, but I try to keep them as fun and as interesting as possible, because my goal ideally is just to build an engineering community. So with that, you have to sort of make the video interesting for engineers and for students and people that are just starting out.
Have your videos gotten more technical over time or less technical?
I think, I'm not sure. I think they have become more technical, but I'm always trying to explain the technical stuff in more fun ways, so that sort of the students and people that don't have an engineering background can still understand them.
And that's why your self-soldering video made me hungry. Let's see, I have a couple listener questions. Maddie C. wanted to know where you get your inspiration for your designs.
Okay, so some ideas are just like, I don't know where I come with them in the shower or something like that. The self-soldering circuit was one of them, for example, because like I said, this has been 5 years in the making, this idea. But a lot of other projects just start by finishing up other projects. So for example, the PCB motor project, I started working on the new version as soon as I finished the rover. And a lot of my projects, I think, are created that way.
Do you have any that you've put on the shelf that you wonder if you'll ever get back to?
Yes, actually, I have some projects that happened before YouTube. So before I was posting video, I was still working on some other stuff that maybe someday I will revisit.
That brings up another question from a listener. William asked, what motivated you to start a YouTube channel? And you've mentioned community. What is the maker community like in Malta?
Pretty zero, I think. The first maker fair that was going to happen got cancelled because of COVID. So, but I think it's improving with time. Let's say that, because currently they're trying to motivate a lot of young students to get into the STEM world. So it's improving. But when I was young, it was it was like it was hard to find a friend that was into this kind of stuff.
What are some of the other motivations to start the YouTube channel?
Yeah, so basically, when I finished my engineering course, I started a startup with my friend, and during that time we were experimenting with a lot of interesting things. But the startup eventually failed because of financial issues. But I remember, saying to myself, like, we have done a lot of research, and sort of documentation wasn't very good. If perhaps we have put all the stuff on YouTube or Hackaday or something like that, maybe it would have been beneficial to others, and maybe also to us, because you actually have to show what you're creating. And that's when I started the YouTube channel, I think, after that failed startup experience.
In school, could you have imagined doing YouTube as a job?
No, I was very shy. If you watch my first videos, they are horrible to watch. But when I was at university, I always, my passion was always trying to invent new things. So at one point we also had a group of 4 friends where we weekly discussed new inventions that we could invent and create as a startup or as a business. And I think YouTube is the perfect place to do that, because when it comes to hardware, it's very, very hard to start a startup hardware, because first of all, any hardware project starts with R&D, and obviously during that phase the whole project could fail, or from the research you have made, it would be unfeasible to do. So YouTube is the perfect place, I think, to do that, because even if something doesn't work, you're still showing people what you've learned, which I think is very entertaining as well.
And the education part is admirable. But if you want to have a new startup with a new invention, if you're giving away all your ideas, how will that work?
So you're referring to as putting them as open source, or
as open source, as explaining them on YouTube? If you invent something that you want to have a startup about, do you think you can be as open about it?
Yeah, I think you can, because as you go along, people will start also putting their ideas in your comments and suggesting if the idea is feasible, or what sort of applications would they use it for. And I think by putting it as open source, you're first giving it to like the community, so anyone out there can build it yourself. And like I said, by having that community, if someone for example copies you or uses your idea, like people still for example, one time it happened on one of my projects. People will sort of still comment that sort of, have you seen Carl Bugeja's video about? So there's still sort of the feeling of a community behind it.
So on your videos, they comment, have you seen your videos?
No, on other.
Okay.
If they, for example, someone tries to create something similar, or stuff like that.
It does happen though. People do comment on,
Yeah.
on people's own stuff and say, "Hey, you should check this guy out. I am that guy."
I've had people ask me interview questions straight out of my book, and it's like, maybe you should check the book. Let's see. William had another couple things to say, but also, please let him know I've been watching his channel from almost the first upload. I really respect his enthusiasm and creativity.
Thank you very much.
Where do you want this to go?
Self-soldering, self-folding, self-driving robot.
Or YouTube star with 10 billion followers.
Yeah.
No, I don't think so. I mean, my goal in life is just to keep inventing stuff, I guess. Even if some of my projects, I think, cannot actually be turned into a viable product. So my goal is to just keep improving some of them and try to create a better future, I guess.
One more listener question from Peter. What kinds of projects would you recommend for someone looking to learn more about designing foldable circuits?
Okay.
Foldable or flexible? Well, let's go with both.
Foldable. Okay. So my suggestion would be to first start with rigid PCBs and use connectors or soldering bridges to connect the PCBs together. If you haven't obviously done a foldable circuit before, because that way it will give you a good idea of the clearances and stuff like that of the PCBs and things that you have to be careful that perhaps don't pop to your mind when you're designing things. I think that's a good way to start. If you have seen my foldable rover, if you have seen the two-wheeled robot, so before the foldable robot, there was a two-wheeled robot. That robot was actually connected with connectors. So it had 3 PCBs in total that sort of formed a U shape and were all connected with connectors.
That raises a question that I had in my mind earlier and forgot to ask. Are you doing anything with the coils or with any of the projects? Some of them you're doing on flex circuits, some of them you're doing on regular PCBs, but are you doing anything where the manufacturing places for the PCBs come back to you and say, what are you doing? This is weird, or this is difficult, or
one of the sponsors is the PCB manufacturer.
Well, that
do you get special treatment for that? Do you get to have special circuits?
No, I don't think so. I mean, they sponsor everything that I ask for, but they do come up with, like, because their marketing team is different than their technical team.
Yeah.
So when it comes, for example, to flexible stiffeners for flexible PCBs, I tend to either, for example, the foldable rover had around 6 of them. So they do come back just to, for example, to verify if they have understood the file correctly, or like how many stiffeners do we have. I am working on a new project, for example. It's just a small actuator, but for this so this actuator has a flex share. I'm not sure if you know what flex shares are. They are used in plastic normally. There's a lot of 3D prints currently with flex shares and stuff like that. They're really popular, and I'm trying to integrate them into PCBs. And for this specific design, I had the same model like for like 10 times. And for them, seeing all these stiffeners got them crazy. So
stiffeners has been one of the areas they've asked about. Anything else?
Yeah, the shape. Some of my my shapes, for example, I made a wearable heated vest, which was around 70 centimeters big. That was, so imagine a PCB almost as big as 1 meter, very close.
Wow.
So that was strange to them. I once made
Yes.
like a Christmas tree that sort of unfolds. That also raised a lot of questions on their side. It's the RGB ball also had a very weird shape.
Right. Well, I imagine they're getting used to it by now.
Yeah. For every project I submit, I expect a follow-up email from their side. So
going all the way back to the flap actuators, and thinking more about my personal projects.
okay.
Usually when you have them, they're flapping back and forth to their full extent. They're making a large motion very quickly. Can I make that same motion but slowly, or does it have to be fast?
Yes. It can also be slowed down. You just have to tune the frequency of your signals, and it can actually be made quite small. And if you, instead of a square wave, if you create like a triangular waveform, the motion is very organic. It's like sort of, for example, a wink for a bird, stuff like that, because it's not just on off, it's slow down.
Cool. I have an origami jellyfish pattern that I want to try. And so if I get a kit and I get the FlexArc...
If you get a kit.
If you ship the kit that I order.
So you order.
And I get the FlexArc board and the flap. I need another controller, don't I? I need something else to tell it what to do.
The driver actually has an onboard controller, so you can just sort of plug it in and it will work. But it also has an option to provide external signals, so you can also control it with your own microcontroller if you'd like.
Like SPI, I2C, UART.
No, it's just the two PWM signals that drives the H-bridge module.
And can I reprogram the PIC that's on there?
Yes, you can also do that. There's in the datasheet, there's the description about the programming pins and what they are.
Do I still have a PIC programmer? I might.
I'm sure we have a PIC programmer somewhere in a drawer.
All the programmers. Have you tried to get like a heartbeat in a stuffed animal instead of a flap?
Heartbeat? What do you mean?
Like the
Oh, you want to make a haptic engine out of this?
Yes, I want to make a heartbeat.
I think you can do it with the 12-layer PCB coil. Depends on how much you want it to have, how strong you would like the vibrations to be.
How come you didn't make this about 20 years ago when I wanted to put it on a t-shirt? Can you go back in time and make this? 8. You were 8.
Yeah.
To be fair, I mean, the physics of this was there 20 years ago.
Yes.
Yeah.
But those little vibe coin cell motors never worked the way I wanted them to. Do you think this can be a replacement for some of the haptic motors?
Mm-hmm. I'm not completely sure because I have some experience using haptic motors, and some of them produce a large vibration. My goal was never to create a haptic motor. I just wanted to use this for robotic applications and other stuff. But I think if tweaked appropriately, the 12-layer coil can be used as a haptic device as well.
Well, if I get it working, I'll let you know. Carl, it's been really wonderful to talk to you. Do you have any thoughts you'd like to leave us with?
No, it's been really fun talking to you guys. So thank you so much for having me on the show.
Our guest has been Carl Bugeja, electrical engineer and YouTube creator. His channel is Carl Bugeja, which is CarlBugeja. And of course, there'll be a link in the show notes.
Thanks, Carl.
Thank you so much.
Thank you to Christopher for producing and co-hosting. Thank you to DJ at RIT for recommending Carl. Of course, I love all the YouTube origami videos you send me for everyone. Thank you to our Patreon listener Slack group for questions, and thank you for listening. You can always contact us at show@embedded.fm or hit the contact link on Embedded FM. And now a quote to leave you with from Akira Yoshizawa, a pretty famous origami guy. My origami creations, in accordance with the laws of nature, require the use of geometry, science, and physics. They also encompass religion, philosophy, and biochemistry. Overall, I want you to discover the joy of creation by your own hand. The possibility of creation from paper is infinite.